You know how sci-fi movies always have people disappearing and reappearing at will? Well, quantum physicists are almost there, but not in the way you'd hope.
Yep. No teleporting humans just yet. But today, we're diving into quantum teleportation and what it actually means for computing. Spoiler alert, it's a game changer.
And by game changer, she means potentially revolutionary but also mind-bendingly complex and frustrating.
Hey, progress isn't always straightforward. But this latest breakthrough from Oxford University? It could help solve one of the biggest problems in quantum computing, scalability.
Ah yes, the age-old issue of making big things work without collapsing under their own weight, much like my enthusiasm for human teleportation.
Haha. Well, think of early computers, massive machines taking up entire rooms. Quantum computers are in that stage now. Expanding them is hard.
And adding more quantum processors is like stacking cards in a wind tunnel. The more you add, the more fragile everything becomes.
Enter quantum teleportation. But, fair warning, it's not the Star Trek kind.
No beaming up, Scotty. Instead, this is about transmitting information between quantum processors using quantum entanglement.
Which is basically when two particles are so linked that if something happens to one, the other responds instantly no matter the distance.
It's like having a long-distance relationship where you actually know what the other person is thinking, without needing passive-aggressive texts.
That's an oddly relatable analogy. Anyway, the Oxford team successfully teleported an entire quantum algorithm between two processors 2 meters apart with 86% accuracy.
86%. Not bad. It's like sending a complicated text message and only having mild autocorrect disasters.
Given how sensitive quantum information is, that's a big deal. Previous teleportation experiments only transferred individual quantum states. This was an entire algorithm.
Which means we're one step closer to making large-scale quantum networks, basically a quantum internet.
Exactly. Instead of building one massive quantum supercomputer, we could connect smaller processors, making computation way more scalable.
Of course, there are still challenges like keeping entanglement stable over long distances and reducing errors.
True, but if we crack those, quantum computing could explode in power. Right now, processors top out around 50 qubits. To solve real-world problems, we'll need millions.
Millions? Great. So we're basically trying to keep 1 million kittens in a perfectly synchronized dance routine.
That's oddly accurate. But even with today's quantum computers, we're already seeing mind-blowing results.
Like Google's Willow chip solving a problem in 5 minutes that would have taken a traditional supercomputer quadrillions of years.
Mind-boggling. And that's just the beginning. Imagine what quantum computing could do for medicine, materials science, or AI in the future.
Right, because nothing could go wrong with a super powerful AI running on a quantum computer.
Always the optimist.
That's what I'm here for.
So, to recap, quantum teleportation moves information, not matter.
It could help make quantum computing scalable.
And while we're not teleporting people just yet, the potential for solving huge problems is limitless.
Until, of course, quantum AI takes over and decides we are the problem.
And on that cheerful note, thanks for joining us.
Come back next time, if you haven't been quantumly erased.
Bye for now.